Good afternoon, everybody. Welcome to today's Omicron webinar. Omicron is dedicated to turning data into significant business outcomes by imagining, developing, and evolving innovative solutions that meld IT and engineering principles. I am Gary Clayton, your moderator, and we are so glad you could join us. Today, we are here to learn how to move up Pi asset analytics so that your Pi data can more easily be used in supporting your corporation. We are here today to learn how our organizations can quicken their movement along the road to digital transformation by using OSIsoft's PE to AF utility. David Soll, Chief Technology Officer of Omicron, is going to provide both practical direction and insights on how to execute that move. David has more than 25 years of deep technical experience working with and helping develop portions of the OSI Pi suite of products. In fact, David was the developer of OSIsoft's PE to AF utility. Now, I am happy to introduce David Soll, Omicron Chief Technology Officer. David?
Hi, thank you, Gary. Okay, so let's get started, and let's first discuss a little bit about why would you want to move from performance equations to AF analytics. And there are really 5 major reasons. One is the AF analytics is a lot more scalable than the performance equations. Once you get over 10,000 performance equations, that may start to slow your Pi system. Also, keep in mind that the performance equation engine always runs on the Pi server, whereas the PE analytics can run on an independent node, so it gives you much more scalability. Another nice feature is that templates allow you to easier administrate. For example, lots of formulas are actually identical, except you're pointing to different tags. With an AF analytic, you're able to create a template that has a generic formula, and then it's abstracted by the actual elements that they're tied to, where the element then has attributes that point to the appropriate tag, but you use the same formula in different elements. And now you can edit a single formula and affect lots of different calculations all at once, because they're all really the same calculation. PEs don't really have a backfill. There is the recalc engine, which doesn't really do a refill. It'll only recalculate events that have already been calculated. So if you bring your Pi server down, you normally say, oh, no big deal, we're buffering and all the data will come back when we bring it back up. But that's not true for any of the performance equations. None of the performance equations will get calculated, and there's no backfill utility to actually go and recalculate those that you've missed. On the other hand, with AF Analytics, it has a full backfill capability. So what's also nice is I can build a new calculation today and have it backfill for the last year. So even though I just created the tag today, I can have a full year's worth of data very quickly. The scheduling capabilities of AF Analytics is also much more robust in that, in addition to having both clock and natural, the natural scheduling in PEs is for a single tag only, whereas in AF Analytics, you can actually trigger on any of the input tags. And the AF Analytics also has better high availability options for an NHA environment. So, what are the requirements to automate it? That would be an application, which you're going to see in a minute, that will migrate performance equations to AF Analytics. Otherwise, you would have to do it one by one, and that would be kind of painful. One of the key things of that app is to be able to utilize templates, so that if it sees multiple calculations that are really the same, just pointing to different tags, make it into a template, and then generate the individual elements with using those calculations. Identify the best element to hold the analytic. Every AF analytic is tied to a particular AF element. As a result, where do we put each one of those? So we have to figure out the best place to put it. And I'll show you how we do that in this utility. One of the things, though, is no matter how good your algorithms are to figure out where to put things and the settings you want to use, there's always going to be one-offs and things where you want to modify it. So as a result, any of the settings generated by the migration utility should be able to be overridden so that instead of using the default, you can do something special, because everybody has special cases, and that's always going to be the case. One of the other issues is, if you're going to have an AF analytic and it's tied to a particular element, that means all of the tags have to be represented in AF attributes for each element where there is that calculation. What if you don't have all of them? So we have to add extra attributes to elements in order to be able to make the calculation work properly. Another key thing is you want to be able to validate the results before actually moving over. It would be nice to be able to check to make sure, are my PEs and my AF calculations going to end up being the same? And you'll see in some cases they won't be. Sometimes they'll be very close, because maybe we're working with single precision versus double precision, or vice versa. So as a result, you want to take a look at the results and make informed decisions about what calculations to migrate and which ones not to, because of the differences. The other thing is you want to be able to store all of your configuration and customizations that you've made, so that if you're going through a lot of these conversions and you're making lots of edits, you want to be able to save where you are and be able to come back and continue where you left off, so that it doesn't have to be done in a single session. So the solution is a wizard-style user interface, and it has multiple screens, one for getting AF information, one for getting PI and PE information, one for translating all of the parameters, and which are giving you the defaults and how to name elements and attributes and so on. One is to read and analyze all of it, then generate AF analytics, validate them, and then what I call finalize, and we're going to go through this. All of the code is available on OSIsoft's GitHub at this URL, github.com/OSIsoft. If you go there, you'll be able to find it. The source code is all there, but it's also compiled, so you can just take the executable and run it if you want. But the nice thing about having the source code is now you can customize it, so that if the rules for picking an element that you want to use for the calculation, or the rules for configuring the names, or something you want to change that algorithm, you can actually go into the code and make changes to it and customize that. So all of the data, all of the configuration is persisted, and it's stored in the AF database itself. And this way, when you go into the app, you do some work, you can get out of it, and you can come back in from a different node, and it'll pick up where it left off. You don't have to continue on the same server. The utility does not have to run on the Pi server. It does not have to run on the AF server. It can run on an independent node, as long as you've got the AF SDK installed. Rather than running you through some of these slides, what I'm going to do is we're going to take a look at the actual app here. And here it is when we first started up. So as you can see, it's a wizard. It has the welcome, the AF, source PE, and so on, all of these things. So it gives you the welcome, and all you do is you click next. And then it says, okay, what is the AF server you want to use? So of course it's going to have a list of AF servers. It'll default to whatever your default AF server is. You can select that. From there, you then pick the AF database. I have a database I call PE to AF. Let me show you the PE to AF database. This is just a small sample database. And what I want to do is I want to use the PE root and put everything, all of my new calculations into elements under that node. What it will do is it will look at all of these other nodes and see if any of the calculations fit in one of these. So if I go to one of these I'll see, okay, notice I have 2 tags defined in each one of these nodes. This tag is pointing to random 03. This one's called random 03 squared. So it will look at those tags, and if those tags are needed for the calculation, it'll say, oh, this might be a good element to put the calculation into. Of course, the calculations that I happen to have don't really fit into these. So again, the root element, we're going to put it here, as I just showed you. Now, this next one, it's called allow this tool to enable the template's allow extension setting. That's kind of a mouthful. So let me just show you what I mean by that. If you go into your library here and you look at a template, let me pick one template. We only have a couple templates. Here's a template. Notice this checkbox, allow extensions. If allow extensions is not checked, then what that means is when I go to an element that's based on it, and here's an element that's based on it, if you look here, see it's based on that template. What happens is I can't add an attribute. Notice it's not there. See, if I go up here, which is not based on it, I have a new attribute option. If I go here, I don't. Which means if I'm going to go and create an AF calculation in an element, and that element is based on a template, and the template is not allowed to be expanded, then if I don't have every attribute that I need, I can't add any more to it, so I can't use that element as one of my targets. So if I hit this allow, it'll actually go in and modify the template if it needs to, only if it needs to. All right, we're going to leave that off for now. Now, if it finds more than one formula that happens to be the same formula, just pointing to different tags, it'll create a template and then generate the element based on that template, which will then have all of the attributes and share the same formula. On the other hand, if I change this to do not create templates, no templates will be created. It'll just create new AF elements and all of the attributes within those elements that are needed. So I'm gonna leave it on. Go ahead and create templates. And then the base template. What the base template does, it gives me a list of all of the other templates. Here's my one that I happen to call base. What that will do is then, if you go back to here and you look here, you'll notice when I create a new template, this template is based on the base template. This base template is based on nothing. All right, so I can base my templates on another template, so it inherits from another template. When I have this setting blank and I have to create a new element or a new template, it'll just create it not based on any other template. If I have it on base, it will create it based on that base template. And notice in this case, base is the name of the template that it's working from. So it will use that as the basis for either a template or the element. All right, so then we hit next. And now we have to enter the PI and PE information. Okay, what is the PI server where the data is going to come from? You'll get a list of all of the known PI servers. Over here, the point source. Now, typically, the point source for a PE is going to be C. So I guessed at C ahead of time, because that's going to be most common. Notice when I hover over it, you get IntelliSense giving you some help. But it'll list all of the point sources that it finds on that particular server. So if you, for whatever reason, change the point source of the PEs, you can handle that. The next thing it needs to know is it needs to know all of the scan classes. Well, the scan classes are all defined in the PyPE-sched.bat file. So what it can do is it can actually go and read the PyPE-sched.bat file. So if I click on this button, it'll go out, and since I'm running on the Pi server, it'll already have the right address for the PyPE-sched. If not, all I have to do is I can go up here and click, and I go to //server/C $, as in the C drive, and hit that, and it'll be in the right directory, and then you can select that PyPE-sched. Once you select it, it reads it, and it says, oh, look, it found 3 scan classes. Scan class 1 is once a minute, scan class 2 is every 2 minutes, scan class 3 is every 30 seconds. Or you can manually put in scan classes and do it by hand. Of course, it's a lot easier to go to PyPE-sched.bat because the scan frequencies are not any place in Pi itself. It's all in that batch file. So once you have that, you can click on Next. And here is all of the defaults for naming. So for example, if I need to add an attribute for an input tag, the name of the attribute will be attribute and then a number. So it'll be attribute 1, attribute 2, attribute 3, because I have no other way of naming them. And I need them to all be unique. So these are prefixes. All right. The output tag, which is really the PE tag, its attribute will be named output. Output 1, output 2. So you can have multiple PEs move into the same AF element. So as a result, by having numbering after the word output, we're able to have multiple calculations within the same one. Also, sometimes formulas have a constant, right? Let's say you're doing you're just multiplying by 2. Well, that 2 is a constant, but then in another formula, you're multiplying by 4. Well, what we can do is we create an attribute that's not a pointer to a Pi tag, but is actually just a fixed value attribute, and we'll name it constant 1, constant 2, constant 3, and so on. And this will allow us to make our templates a lot more robust in that now we can handle all of the constants as well as the Pi tags, the variations between them. The element name is a little bit different, and notice the IntelliSense gives you all of the information, so if you just hover over it, you'll get a lot more information on it. But wherever you put %PE% is going to be the name of the PE tag. And then it'll append a number after it. So it's entirely possible that by using the numbering will automatically make sure that it's always unique. A PE analytic always has to have a name, so we call it analysis 1, analysis 2, analysis 3, and template prefix. If I'm going to create a template, what am I going to call a template? In this case, I call it template. In this case, let's call it PE. Let's call it converted PE, just to give it a different name. Hit next, and lo and behold, it goes and it does an analysis. Now, the amount of time that it takes for this screen to pop up is going to vary, because what it has to do is it has to go through every single performance equation, look at all of the tags that are utilized in that performance equation, then walk through your AF database looking for what element has all of those attributes in it. And what I do is I have a point system in there so that when it walks through, it looks at an element and it says, oh, one tag, this element has one of my input tags, but I've got 5 input tags. This one has 3 input tags, so it's going to have more points. So what I do is for every input tag that's in an element, it gets 1 point. For every output tag, it gets 1.5 points. So it then takes whatever has the most point count, and that's the element where we will put the PE calculation. If a PE calculation ends up not finding any elements with any points, so it's all 0 points, then it will create its own element for that calculation. Also, by the way, if it hits an element that's based on a template where I'm not able to expand it, if it doesn't have 100% of all of the input and output points, then we consider that as 0. There's no match because we can't use it. So what you can see here is we have some of these have templates in them. Okay, so here, this particular formula is unique, so there's no template. This formula is not unique. Let me widen this. So here's our converted PE. This is the name of the element template. Converted PE 3, 2, 2. So these two are the same. Look at this. Okay, string of random 01, string of random 02. So these are really the same formulas, just pointing to different tags. So over here you can see this is the original formula from the PE. Over here to the right of it, you have the formula that's going to go into the AF analytics. So this is the translated formula, the output. You can see the scan frequency or trigger over here. In this case, all of these happen to be time-based. And notice any one of these, I can click Edit, and I can modify any of the particular components of this. So I can edit each and every one of these. Of course, if you wanted to edit each one by one, it would be pretty tedious, especially if you have a lot of them. So what you can do is you can select multiple rows, and down here you can hit Edit Selection. And now things that are common between all of those I can edit. So for example, you see this Migrate button? I can disable Migrate by doing this, and now it's not checked, so this particular tab won't get migrated. But if I select a bunch of these, I can then edit the selection and turn off the migrate, and now all of these will not be migrated. So I can do groups of these at a time. To make it also easier, I can also change the way that this is showing me the information, so I can group it by template. So now these are all with no template. Here are all of the ones with other templates. So I can edit this template rather than select all of the things. Or I can group by point source. The reason that I picked point source is point source typically tells you where the tag is coming from. And when I say point source, it's not the point source of the PE, it's the point source of the input tags. So if the input tags have a particular point source, they're probably coming from a particular interface, and therefore they're all coming from the same location. Of course, you can go no grouping. The other thing you can do is you can even filter. So if I just type fast, and only the tags with the name fast in it show up. So then, of course, it makes it very easy for me to do a selection and work with it that way. Okay, so we've got a bunch of these selected, we're all ready, and we're ready to move on. We've edited, we've made all the changes we want. We hit next. It goes and it saves everything, compiles it all, and now here we are ready to migrate. So to migrate, we hit this. Keep in mind that the migrate process will build our PE analytics, our AF analytics, but will not enable them, and it will not disable the performance equations. So making this move will do no harm. Every PE will continue to operate as it was before the migrate. It's just that now you have all of these AF elements that it's going to create, and but the calculations will all be disabled. So let me click migrate. Notice it's ready to migrate 39 of them. So now it's migrating them all. Okay, and we're done. So now we can move beyond migrate and we can validate. So before we do anything, now that we have the formulas built in, we can actually go and validate, and we're going to actually execute the performance equations and the PE analytics at the same timestamp. I look at the scheduler and use the schedule that we put in and make sure to do the calculation at the same time for each one of these. So here's all of the results. Let me widen this a bit. So here you can see this one says batch 9, this one says active. Look at this, there's a slight difference, 1.6617, 1.6617. So there's a slight difference. Why? Because in AF we're going to double precision, in PE we were single precision. Now right now this slider says show all results. If I just want to look at what's different, here's what's different. So now you can see everything that's different. Well, why is this different from that? Well, because the PE gives me a period after the 9, the AF does not. And that's just how that works. Oh, okay. So but some of the others, what I can do is I can move the slider over a little more, and now it'll only show me mismatches that are within 0.01%, within 0.1%, or within 1%. So here you can now see the differences. And if for any reason you want to save these results, you just click the Save Results button, and it'll save it to a text file that you in CSV format, so you can open it up in Excel or Notepad, whatever you want. Also, if you say, well, you know what, these first two, I want that period, so I don't want to migrate these two, so I'm going to uncheck the finalize on these two, and now I can go hit next, and I can click finalize. And finalize is only going to do 37. Remember, we had 39 before that we converted, but only 37 are going to get finalized. And that should do it. So now we're all finished. So if we go back and we take a look, let me refresh this. We'll go. Notice all of the new templates that have shown up here. And in our elements, all of these new elements are showing up, and each one now has an analysis in them, and you can see it's green, so it's working. If we go to our management, we should see a lot of greens. Here are the two that we didn't finalize. So they're grayed out because we did not enable them. So they're still being executed by performance equations. We didn't actually complete the migration intentionally. But we can always go back and start the application again, let's start the application again, which it's coming up, I think. Here we go. Here's the application. Hit next. Now all of the settings that I had before are still there. So I don't have to do anything except hit next, next, next to get back up to here. Now what I can do is I can go in and I can edit any of these components, and I can say, okay, let's migrate these. Oh. Come on. There we go. Edit selection, migrate. There we are. There's only one. Yeah, I didn't get that checked for some reason. Don't want to check it. Oh, I can't check these because the reason I can't check them is if you look, the status is migrated. We already migrated it, so I can't tell it, go ahead and migrate it. I have to do the ones that are here. There we go. So it won't let me. Okay, these are ready to migrate, so I can do that. Hit next. Go ahead and migrate those. 5 more. Okay. Next. Now we've got 7 calculations. Remember, because there were 2 that weren't migrated before, that weren't finalized, and you see these 2 are still unchecked because they're not finalized. But I can look at all of these others, look for what's different. And notice these have some of the dot issues also, but I'm going to leave them in and I'll let them finalize. And they're done. So we can keep going back in and out over and over again. So, in review, the steps to follow in doing the migration is identify the exceptions, check your AF, make sure your AF database is ready for it, make sure that your nomenclature and standards are all stand up to it, and if they're not, maybe you need to modify the program or just do a lot of hand editing. Configure the utility, check all the rules. I recommend staging it, check it out, and do any exception handling, meaning anything that didn't quite fit the norm, go back and handle those guys. Now, one of the things that we're going to be offering is an initial assessment for $1,500, where we can do it either remote, or if you just send us an SMT output of your PyPE points and do an AF database export, we can deliver to you an assessment report which really tells you how well the migration will go ahead of time. In addition, we also offer assistance in actually doing this. Our standard rates are $150 an hour, and the initial assessment is a not to exceed, so if we don't use up the time, that's fine. So, you can contact any of these people here. Myself on the left, Gary, who's our moderator, and Bernard, who's also on the line right now. Contact me, or Gary, or Bernard. And Gary, do we have any questions?
We do have a couple of questions. The translations. Does it have an option for adding more variables in the calculations for bad val checks, or any other way to handle error checks?
No. Right now, it does just a straight translation. So if this is what the PE is, that's what the AF analytic is. It doesn't It doesn't try to change it. It doesn't use any sort of AI or smarts to do that sort of thing. It's purely a translation. Now, that doesn't mean that once you've moved it over that you can't go in and edit it. And in fact, one of the things you can do is let it do the migrate, but don't do the finalize. Then you can go in and edit it in the AF editor, which is a lot more robust because it's got the IntelliSense and it's more like working in Visual Basic or something like that. And it allows you to make the modification, and then you can finalize it.
Okay, we also have a second question from Monroe, and that is, do you have any plan for utility for ACE to AF migration?
That's actually a pretty common question, and the answer to that is no. The problem with moving ACE over to AF Analytics is ACE uses Visual Basic, VB.NET or VB6. I don't know if anybody still uses that, but in any case, with VB, there is no limit to what I can do. I can open up a SQL database, I can open up files, I can send emails, I can screen scrape HTML pages, I can do anything I want, and it has, and it goes way beyond what an AF Analytic could possibly do. Also, one of the other things that AF Analytics is not good about doing is iterative kind of calculations, whereas in VB it's very easy to do a for next loop. So doing an automatic translation is nearly impossible in my opinion. I don't know that you're going to find ever any tools to do that. I want to thank everybody for attending. And hopefully you got something out of this, and you know, if there's anything we can do to help you out, please feel free to contact us. You've got our emails, they're up on the screen, and hopefully we'll be hearing from you.
Okay, and with that, we'll end the seminar right now. Thank you so much for your attendance. If there's any questions, again, afterwards, feel free to send it to us via email, and we will address them with you. Thanks a lot.